Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss energy level diagrams. Let's begin. Let us consist of an atom. In an atom, that is consist of a positively charged in that of massive nucleus. In nucleus, that is proton plus neutron, which is highly positively charged, and negatively charged electrons are revolving around the nucleus in different permitted orbits. Here are the electrons revolving around that of nucleus. In different permitted orbits, and the electrons revolving in a particular permitted orbit have a fixed amount of energy. If the radius is large of that of particular orbit, accordingly greater will be the energy of that particular electron present on that of orbit. As a result, the outermost orbit electrons have more energy than that of inner orbit electrons. Therefore, the energy level diagram is the diagram that representing the energy of different orbits of an atom. That be the edge of nucleus, at radius r1 is the first energy level at radius r2 we have second energy level radius r3, third energy level radius r4, fourth energy level and so on. Which one is the energy level diagram? In that of figure, the first orbit of radius r1 represents first energy level, then second orbit of radius r2 represents second energy level, third orbit of radius r3 represents third energy level, and so on. If the orbit of an electron is larger then the energy level is higher, as we see. What is energy bands? To show energy bands, in an isolated atom, the electron in a particular orbit have a fixed amount of energy, as we see in that figure. However, the energy of electrons in an orbit of an atom in a solid is greatly influenced by the closely packed neighboring atoms. If we consider a solid here, that is a solid, there are huge number of atoms, and these atoms are closely packed. That atom has its own energy level, and its neighboring atom also its own energy level, and the energy levels of these atoms are influenced by their neighboring atoms. Okay. So, what are energy bands? The electrons in an orbit of atom in solid has a range of energies, and this range of energies of an electron in any orbit of an atom in that of solid is known as energy bands. Look here, what it say. If we consider an isolated atom, so at a particular energy level, here let it be K cell, L cell, M cell, like that. In K cell, the electrons present in that of K cell has a particular energy value. Similarly, in case of solids, there are a huge number of atoms. If we consider that atom, and the electron present in the K cell of that atom is what? Is quite different to that of electron present at the K cell of its neighboring atom. Okay. So, there will be a energy difference, or we can say that energy is vary in a range, and the collection of these energy levels of a particular electron present in that of orbit is known as energy bands. If we plot the graph, or we can show the energy band in terms of diagrams as at radius r1, the first energy band, for that atom, the electron present at radius 1 have a particular energy, and again this atom, that atom, and all the atoms that are present in that of solid, and the electron in that of radius r1 has a energy range, and that energy range is nothing but first energy band. Similarly, for r2 radius, the electrons are present at r2 radius throughout that of solid atoms have the energy, we call it as second energy band. Similarly, at radius r3, it will be third energy band, and so on. This one is the energy band diagram. In solids, there are a number of energy bands, but mainly we are dealing with three numbers of energy bands as valency band, conduction band, and forbidden band. The band energy band as valency band, conduction band, in between these two bands, that band is the forbidden band. The energy bands in solid. Let us take a brief introduction towards valency band, conduction band, and forbidden band. So, what is valency band? Valency band consists of a range of energies possessed by valency electrons. So, what is valency electrons? Valency electrons are those electrons that are present in the outermost orbit of an atom. So, the valency band, that is consist of the range of energies possessed by valency electrons, and valency electrons are those electrons which are present at the outermost orbit of an atom. If we consider a solid, so what are the what are the electrons present at the outermost shell of these atoms present in that of solid in a range of energy, and that range of energy is nothing but valency band. Similarly, for conduction band consists of a range of energies possessed by conduction electrons. So, what is conduction electrons? Conduction electrons are the free electrons and these free electrons are responsible for the conduction of current in a conductor. Through the conductor. So, conduction band consists of range of energies possessed by conduction electron. So, what is conduction electrons? Conduction electrons are the free electrons which are responsible for the conduction of current through that of conductor. This is the conduction band. Next, forbidden band. Forbidden band is the separation between valency band and conduction band on that of energy band diagram, and this forbidden band is also known as band gap or energy gap. Forbidden band in between conduction band and valency band, also we call it as the band gap or energy gap, that is also known as band gap or energy gap. Forbidden band or band gap or energy gap. Next, by using the concept of energy bands, we can classify solids. Classification of solid as insulator, conductor and semiconductor on that basis of energy bands. What are insulators? Insulators are those materials through which electric current can't flow, and in that of insulator, the valency band is completely filled, but the conduction band is totally empty, and the energy gap between the valency band and conduction band is very large. So, if we plot the energy bands in insulators, here is the valency band, there is the conduction band, valency band is totally filled, that is the valency band. Here is the conduction band, that is totally empty, and the energy gap is around 15 electrovolt, that is for insulator. And the energy bands in insulators. In that axis, that is the band energy. Band energy. Next, for conductor, conductors are the materials through which electric current can flow, and in conductor, the valency band and conduction band overlap each other, and the forbidden band is totally absent. Since the conduction band and valency band overlap with each other, therefore the forbidden band is totally absent. The valency band and conduction band both are overlap with each other. This is the conduction band, the valency band, band gap is 0. The energy bands in conductor, in the band energy. Next, for semiconductor, in semiconductors the valency band is almost filled, but the conduction band is almost empty, and the energy gap between the valency band and conduction band is very small, around 1 electrovolt. If we plot it, the valency band, that is entirely filled. The conduction band, it is partially filled, and band gap in between conduction band, valency band around 1 electrovolt. That is valency band. Here is for conduction band. With the energy level diagram, energy bands in semiconductor. It's the band energy. So on that basis of conduction band, we classify solid as insulator, conductor and semiconductor. So with the help of this video lecture, we understand the concept of energy level diagram, energy bands, various types of energy bands as valency band, conduction band and forbidden band. Just an idea of valency band, what are conduction bands and what are forbidden band. On the basis of that energy band, we classify solid as insulator, conductor and semiconductor. Insulator, conductor and semiconductor. So with this useful and informative notes, let me wind up this session. Thank you.